Okay, we've been working on the planning workshop. We've been solving the exercise for quadratic function. We already did step 1, step 2, and step 3, which was the intercepts using quadratic formula. Now what we're gonna do is solve the rest of the steps 4, 5, and 6. We're gonna solve them together so you understand what's the difference between each one of them. Okay, so let's begin with step 4, domain and range. Okay, the domain basically means in which places do we have X on the graph, or kind of like saying if I try to trap the graph horizontally, like from one place horizontally to another place horizontally, from where to where am I gonna have to catch that drawing? In this case, like you might believe, from -2 point something to 4 point something, which is not the case. Let me show you why. If we only analyze the graph like in this place, we might think, okay, the graph begins in X, okay, the graph begins in -2 and it ends in 4. You might believe like, okay, let's try to trap the graph, okay? So it will be from -2 the X and it will end on 4. That will be like the domain. You might think that, but it's wrong, but you might think, okay, the domain is from -2 to 4. No, because if you move up, you're gonna see that the drawing is actually moving to the left forever. It's moving slowly, but it's always moving to the left, and it's always moving to the right. So actually there's no way to catch it. Like you might think, okay, so from -3 to 5, you can see that in these places it moves and it passed -3 and it passed +5. So the graph actually is moving forever. If I try to catch the graph, I will have to kind of like trap the entire plane from -infinity to +infinity. So how can you say that you cannot trap the graph, that the graph is in all of the numbers? You do that by putting a capital R. Okay, capital R represents all of the real numbers, so the answer for the domain will be R, the real numbers set. Okay. Now, what about the range? The range is kind of like the same idea of the domain, but in this case, I'm not trying to catch the drawing horizontally, I'm trying to catch it vertically. And in here, finally, we have the first type of domain range stops that are not completely R or just a number. We finally have something that is a portion of the drawing. Like you can see the drawing is going up forever, right? But what about the other direction, downwards? You can see that the drawing actually ends on -9 and it's no longer going any other place under -9. So I could trap that drawing if I say, like, let's say I'm gonna catch it in -9, and from -9 until the infinity positive I will have the drawing. I could do that, and basically that's how you capture one of these drawings. It will be from -9 on the y-axis until +infinity, because that thing goes forever. So the range in this case will be from -9 to +infinity. And that's how you should write it. Okay, -9 closed and +infinity open, because we always leave the +infinity open. Okay. Okay, step 5. That will be step 4. Like the domain will be R, the range will be -9 from to +infinity. Okay, step 5 is the type. You can easily see the type by checking the type of drawing that you have, because the drawing looks like a U. That's a parabola. The type will be a quadratic function. Also, the exercise kind of like tells you x squared, which is the greatest term in this case. That will tell me that I have a quadratic function, so the type will be quadratic function. Okay, that will be step 5. Only finding the type. Type is quadratic function. Okay. Now let's go with step 6, the growth intervals. Okay. which are the growth intervals for this thing? We have three types of intervals: increasing, decreasing, and constant. Remember that increasing means where is the drawing going up. Decreasing means where is the drawing going downwards. And constant means where is the drawing exactly horizontal, like not going up, neither going down, only horizontal, stay constant. Okay, so we're gonna have to check the drawing. Okay, where do you think the drawing is going up? You might be thinking, from -9 it's going up. Not exactly. Okay, when we try to analyze the growth intervals, we need to check horizontally, like the axis, from where to where. You might be thinking, like, what does that mean? Okay, that means this. Okay, you can see that this section is going up, right? What is this section? This section is not -9. This section is from +1 to +infinity, like 1, and to the right that will be increasing because that's where the drawing is going up. So increasing will be from 1 to +infinity. From 1 to +infinity, and you leave the infinity open because we never close infinities. Now what about decreasing? Okay, where is the drawing decreasing? Okay, the drawing is decreasing on the other side. And what is the other side? Okay, let's check it out. Okay, this place where I colored in red, that will be the other side from number 1. Okay, and you can see that the drawing is going in downward direction, yes, in this place. So it will be from -infinity is coming down until number 1. Okay, because after number 1 and the axis, it starts going up. So it will be from -infinity to 1. That's where the drawing is decreasing. So you're gonna have to say from -infinity, which means the left direction, okay, from left to +1, and you close 1. Okay. Now what about constant? You can see the drawing is never horizontal. Okay, the drawing is either traveling in a downward direction or it changes to an upward direction, and that's it. There is no horizontal line in here, so constant will be empty. Okay, this circle with a slash means empty, that there is no constant interval. Okay, and that will be steps 4, 5, and 6 for a quadratic function like the one that we had before.